Hello, Algebra 2 student, and welcome to this lesson on solving quadratics by completing the square. In this lesson, you'll be provided with some problems where you will be using that particular method to solve quadratic equations. I do want to thank the people at All Things Algebra for providing the problems that you're about to see. So let's just go and get started with solving quadratics by completing the square. All right, so this problem and all other problems that you'll see here are on the current packet of what we're doing. Let's just go and get started with this. So here's problem number two. So we have x squared minus 6x plus 9 equals 20. Now, for this particular problem, what you may realize is that um, this particular problem that we have here, has already a perfect square trinomial. Okay, this right here, x squared minus 6x plus 9, is considered a perfect square trinomial. Okay. And so basically, what that means is that we can actually go ahead and rewrite this like the following. We have this basically becomes x minus 3 squared equals 20. Now, in case you have forgotten why that's why it is, let me remind you that what we have here is something called a B table. And so if I make a B table, so this is B, 1/2 B and 1/2 B squared. Okay. This is our B table. Um, what that basically means is that, B in this case is -6, half of B is -3, and half of B squared is +9. And that's basically what we have. We have the x squared, which is what we needed, and then we have -6x and then +9, because B is -6 and then +9. So we can actually just turn this perfect square trinomial into x minus 3 squared, which is what we did. So we have x minus 3 squared equals 20. Now we're going to do like we did in recent past. We're going to solve this problem using the square root method. And so basically what you'll do is you basically are going to square root both sides. So you have x minus 3 squared, square rooted, and then 20 square rooted. Well, when we square root x minus 3 squared, we have just x minus 3. On the right side, you have plus or minus, because anytime you square root both sides of an equation, you have to write that plus or minus. And then you have the square root of 20, okay? But the square root of 20 cannot be square rooted. So what we have to do is we have to do a factor tree. So we'll come over here and put 20 and try to break it up into factors. Well, 20 is going to be 2 times 10. 10 is 2 times 5. What I see here is we have a pair of twos, so we'll go ahead and circle that pair of twos and then put a box around the 5. So remember, pairs get circled, unpaired numbers get a box. So now I'm going to rewrite this problem. So we're going to have x minus 3 equals plus or minus. Go ahead and write our radical sign. Unpaired numbers go inside, so that's going to be a 5. A pair of twos go out as one number 2. That 2 goes right here. So right now you have x minus 3 equals plus or minus 2 squared root of 5. And then finally, we're just going to add 3 to both sides to get x by itself. And so when we do that, we're going to write down x on the left side. And then since we brought over a plus 3, that's going to be written down first, followed by the plus or minus, and then 2 square root of 5. So therefore, x is equal to 3 plus or minus 2 square root of 5. And as always, I would like for you to write the answer write the solutions separately. So we write our solutions. So our first solution is going to be x equals 3 plus 2 square root of 5. And then or x equals, I don't like that, or, here we go, x equals 3 minus 2 square root of 5. Okay, so those would be my two solutions for this problem. All right, so now on this problem, we are going to actually do the whole complete the square method without already not having a perfect square trinomial. So this is your example. I'll get in this packet. So let's go ahead and just get to it. So the first thing you want to do is you just want to make sure that the x's are all by themselves, and then anything that doesn't have an x gets moved over to the other side. Well, in this case, we have a minus 34 that needs to be moved. So you're going to add 34 to both sides. So that's going to give you x squared plus 8x equals 34. Okay. And so now we check to see if the A in this case is 1, and it is. So we don't have to do any factoring. I mean, we can, but we don't necessarily have to. So yeah, so let me go and write that down. Yeah, A is equal to 1. So we can yeah, factor that out, and we don't have to because A equals, but we don't have to because A equals 1. So at this point, we're just going to go ahead and create our B table. So let's go ahead and make the B table. So here's our B table. I'll put it over here. Again, our B table consists of B, 1/2 B, and 1/2 B squared. So that means that B is going to be 8, because remember, B is always a number in front of X. So it's going to be 8. Half of that is going to be 4, and then 4 squared is 16. Okay, then we're going to circle that 16, and we're going to add that 16 to both sides of our equation. So let me kind of come over here a little bit. So that means we're going to have x squared plus 8x plus 16. Again, that's what we added over, equals, and on the other side is 34 plus 16. So remember, 16 gets added to both sides. So now we can rewrite the left side, because the left side, again, is going to be a perfect square trinomial. So this is a perfect square trinomial, okay? And since it's a perfect square trinomial, then what you'll do is you'll rewrite it as a parentheses squared. So we write our, write our parentheses squared. So that's going to be x plus, and because half of b was 4, it's going to be x plus 4 squared equals, and then 34 plus 16 is going to be 50. So we have completed the square to get it to look like a situation where all we have to do is do the square root method to solve for x. So let's do that at this time. So that means we're going to square root both sides. So square root x plus 4 squared, square root 50. So that means we're going to have x plus 4 on the left side equals, and then again, we write plus or minus because we square rooted both sides. And then we need to try to square root 50, but 50 cannot be square rooted. So what we'll do is we'll go ahead again and rewrite or write a factor tree for 50. So let's put 50 over here and break it up. Well, 50 is going to be 2 and 25, 2 times 25. And then 25 is 5 times 5. So again, we have a pair of 5s. So we're going to circle that pair of 5s. And then we can botch the 2 because it's unpaired. So we come back to our problem. We write our radical sign. The 2, which is unpaired, goes inside. And then the 5, which is a pair, comes out as one number 5. That goes right here on the outside. And then finally, we need to get x by itself. So of course, what we'll do is we'll subtract 4 to both sides, just like that. And that leaves us with x on the left side. And then since we moved the minus 4 over to the right side, we want to write that down first. So it's going to be negative 4. And then bring down your plus or minus 5 square root of 2. So that takes care of x. X equals negative 4 plus or minus 5 square root of 2. And so the last thing, of course, we'll do is we'll write our solutions. So our solutions are going to be written separately. So it means we're going to have x equals negative 4 plus 5 square root of 2, or x equals negative 4 minus 5 square root of 2. Okay, so there you go. There's your solutions, and this is our answer to this problem. All right, here's problem number 4 from this current lesson. So once again, we see that we need to do the complete the square method. You'll notice already that both the x's, both the terms that have an x in it are just by themselves. Negative 30 is already over on the right side, so we're good there. Now, keep in mind, though, that the value of A in this problem is going to be 2, so A equals 2, which means that we need to go ahead and divide that out on the left side. We need to factor that out, okay? And so the way we do that, remember, is that we basically put a 2 on the outside of a set of parentheses, and then simply what we're going to do is we're going to divide 2 to everything on that left side. So in other words, now, probably the negative 30 stays the same for right now. And then, like I said, we divide 2 to both 2x squared and negative 16x. So if I just come over here for a moment and do some side work, I got 2x squared divided by 2. 2x squared divided by 2 is just going to be x squared, which I'm going to put right here. And then we also have negative 16x divided by 2. That's going to be negative 8x. So we put that over here. Okay, so remember, if A is not 1, you're going to have to divide it out like we just did. Going to factor it out to get it to look like how we have it right now. Now, because the inside parentheses has an A equals to 1, basically, we can go ahead and work on our B table to determine what needs to be added. So again, I'll just kind of do the work right here. I'll write B table once again. And again, you make your 3 headings, B, 1/2 of B, and 1/2 of B squared. All right, so B, in this case, is going to be not the original B, which was negative 16, but the B that we have now in our parentheses, that's going to be negative 8. So we're going to put negative 8 again for B. And so now we're going to take half of that, which is going to be negative 4. And then again, negative 4 squared is going to be 16. Why do I feel like I've done this before? Okay, but anyway, half of B squared is 16. So we're going to add that 16 into our problem. So remember that the 16 will be added into the parentheses first. So we're going to have 2 parentheses x squared minus 8x plus 16. That's going to go in the parentheses equals. Then on the right side, we have negative 30. But because we added 16 into the parentheses, we have to basically multiply the 2 that was outside to that 16 that we added on. And yeah, so 2 times 16 is going to be 32, positive 32. So therefore, we're going to add 32 to the right side, not 16. Okay, so remember, whatever A is, you multiply A to the number that you added on to that other side that doesn't have the perfect square trinomial. All right, so now we've done that. So now we're just going to rewrite the problem. The right side actually is negative 30 plus 32. So that's going to, of course, be positive 2. So just leave that as positive 2. On the left side, you have the 2 still from the outside of the parentheses, but then you're going to turn the x squared minus 8x plus 16 into a perfect square trinomial, which it is a perfect square trinomial, but you're going to turn it into a parentheses squared. So basically, it's going to be x, and then whatever is in the half B column follows it. So it's going to be minus 4. So we have 2 parentheses x minus 4, and of course, it's going to be squared. All right, so we have got it to a perfect square trinomial. We turn it into parentheses squared. So now the next thing we'll do is we're going to just go through the process like we did with before with the trinomial, with the square root method. We're going to actually divide 2 to both sides at this point so we can get the squared by itself. So that's going to leave you with just x minus 4 squared equals 2 over 2 is going to be positive 1. All right, so now we have the squared by itself like we've done in the past. So now, of course, what you'll do is you'll need to square root both sides. So square root x minus 4 squared and square root the 1. So the left side will just become x minus 4 equals, and then don't forget your plus or minus. And then can we square root 1? Yes, it's going to be just 1. So right now it's x minus 4 equals plus or minus 1. And so then the next thing we'll do is we'll get the x by itself. So move this up a little bit more. So we need to get the x by itself. So we need to add 4 to both sides, just like this. So that's going to leave you with x on the left side. And then again, remember, whatever you brought over to that side needs to be written first. So it's going to be just positive 4 and then plus or minus 1. So right now we have x equals 4 plus or minus 1. Well, we don't have any radicals here, no square roots or anything like that. So what we're going to do this time is simply just add up or add on to add the equation or simplify the problem. That's what I'm trying to say. So so what this basically means is that we can write this as two things. First, it's going to be x equals 4 plus 1. The other one's going to be x equals 4 minus 1. Again, you can go this far because both 4 and 1 are just, regular integers. So we're going to add, or regular numbers, honestly. So if we add 4 plus 1 on this side, that's going to be x equals 5. The other side is going to be 4 minus 1, which is x equals 3. So therefore, our two solutions, so these are our solutions, x equals 5 or x equals 3. And again, these would be my solutions for this particular problem. Okay, so you always want to make sure that you simplify the problems to the best to the best of your ability. Okay. All right, here comes another example. 3x squared plus 10x plus 8 equals 0. So for the time being, you'll notice that the x's are not basically by themselves. So we're going to have to move something so we can have just x's by itself. This is a good problem. I just thought about it. So what we're going to do is we're going to take the 8 that we see and we're going to subtract that to both sides because we want all the x's on one side. So that means we're going to have 3x squared plus 10x equals 0 minus 8 is going to be negative 8. Now, also remember that we need to also check to see what a is equal to at the beginning. This time a is equal to 3. So I'm just going to write that right here on the side, which means that we are going to have to divide 3 on the left side to all the things on the left side that have the x's. So that's what we're going to do. We're going to factor it out. So we're going to take the 3 and we're going to factor that out and equal it to negative 8. So once again, we'll do some side work. We have 3x squared. We got to divide that by 3, and that's going to be equal to just x squared. So we put x squared in the beginning of that parentheses. And then we have 10x over 3, which does not simplify any further. So it's just 10 over 3x. Okay, so we're going to write plus 10 over 3x. Okay, all right, this is going to be interesting. All right, so now we have factored out the a. So now it's time for us to do our b table to get this to a perfect square trinomial. So once again, I'll just start off my b table. So don't have to keep writing b table. I'm just going to write b, 1/2 b, and 1/2 b squared. So b this time is going to be 10 over 3. Okay, so b is 10 over 3. And then half of 10 over 3 will just basically be 5 over 3 because half of 10 is 5. So it'll be 5 over 3. And then half of b squared is going to be, well, you square the numerator and the denominator. So that's going to be 25 over 9. Okay, 5 squared is 25, 3 squared is 9. So now we're going to add that 25 over 9 to both sides of the equation. So I'm going to circle it. And so now we're going to start off by putting it on the left side into the parentheses. So that means we're going to have 3 parentheses x squared plus 10 over 3x. And then we add it on 25 over 9. Okay, and then equals on the right side, we have negative 8. And then what do we add to that? Well, remember, we have to multiply what we added into the parentheses, which is 25 over 9, by the a. So this is going to be multiplied. It's going to be 3 times 25 over 9. So I'm going to do that right. I guess I could do that over here. So it'll be 3 times 25 over 9. If you're not sure, you're welcome to use a calculator for this particular part. Just make sure you're showing the work like this. And so, and I have no calculator in front of me, so, but I do know that 3 times 25 is 75. So it's going to be 75 over 9. And I believe that can be reduced to 25 over 3. Okay, because you divide both of them by 3. So that's what we're going to add to the negative 8. Negative 8 gets added by 25 over 3. Okay, all right. So at this point, we're now going to rewrite everything. So let me zoom in just a little bit. So we know that on the left side, we have 3, and then we're going to have a parentheses squared. Well, we know that it's going to start with x, and then we go to the half b column. So the half b column tells us it's going to be 5/3. So we're going to write plus 5/3 and then equals, and then we need to add -8 to 25/3, and I believe that's going to be 1/3. Again, you can use your calculator for that, but I believe it is going to be 1/3 because -8 is 24/3, -24/3, and -24 plus 25 is +1. So yeah, it's going to be 1/3. All right. So now we have got our parentheses squared. So now, of course, we now need to move the 3 that's on the left side outside that parentheses. We do that by dividing 3 to both sides. So basically, it's like 1/3 divided by 3. I know it's looks kind of weird, but what that means now is we're going to have x plus 5/3 squared, okay? And then on the right side, it's 1/3 divided by 3. And make sure that if you're using like a Desmos calculator or whatever, that you basically make the fraction and then put 1/3 on the top and then 3 on the bottom, and you will get 1/9. Okay, so it's gonna be 1/9. Okay, so we have x plus 5/3 squared equals 1/9. All right, so now the next thing we're going to do, of course, is we're going to square root both sides. So we're going to square root the x plus 5/3 squared, and then we're going to square root the 1/9. Okay, and so of course on the left side, we have just x plus 5/3 after we square rooted it equals, and then it's going to be plus or minus, because remember when you square both sides of the equation, you write that plus or minus, and then you write the square root of 1/9. Well, the square root of 1 is going to be 1. The square root of 9 is 3. So it's going to be plus or minus 1/3. And then we just need to move the 5/3 to the right side. We do that, of course, by subtracting. So we're going to do minus 5/3, minus 5/3. And so that's going to leave you now with x equals, again, you write what you brought over before the plus or minus. It's going to be -5/3 and then plus or minus 1/3. Okay. And again, since both of these are numbers, then all we got to do at this point is rewrite it into 2 different equations. So just draw an arrow, draw an arrow. So, this can be our solutions. So we're going to have x equals -5/3 plus 1/3. And then we're going to have x equals -5/3. Sorry about that, 5. -5/3 minus 1/3. Okay, there we go. All right. And so now we just need to add. And again, you can use your calculator if you need to, but I'm not using calculator. So we got -5/3 plus 1/3. Well, that's just -5 plus 1. So that's going to give you -4/3. Okay, so that's one solution. Um, the other solution is going to be -5/3 minus 1/3. Well, -5 minus 1 is going to be -6, but then it's going to be -6/3, which is going to be just -2. Okay, so therefore, our 2 solutions are going to be right here, -4/3 or -2. Okay, and so that is, I know a lot of stuff there, but there is our equation and our solutions for solving this. All right, let's go to this problem right here. It says 3x squared minus 30x equals 69. So once again, I can identify that the value of a is 3. So that means we will be doing some factoring in just a moment. We also see that the all the x's are on one side. X squared and x are already on the left side. We have that other number, 69, on the right side. And so that's not affecting anything right now. So let's just go ahead and just factor out what we can on the left side. So we're going to start off by factoring out that 3, and we're going to make our parentheses, and then of course that's equal to 69. Well, what we're going to do now is we're going to take, we're just going to divide 3 into both of the terms that have x in it. So again, I'll do some side work. we got 3x squared divided by 3. For 3x squared divided by 3, of course, it's going to be x squared, which I'll write down first. And then we'll do negative 30x divided by 3. That's going to be negative 10x. So we put negative 10x or minus 10x after that x squared in the parentheses. All right, so now that we have factored out the a on the left side, we're going to again do our b table. So let's go ahead and make our b table. So again, I'll just draw the headings. So we got b, 1/2 b, and 1/2 b squared. So that means we're going to take b, which is in this case, the b that's in the parentheses, it's going to be negative 10. So we put negative 10. So we'll take half of that, which is going to be negative 5. And then the negative 5 squared is going to be a positive 25. And that's what we have to circle, because that's going to be what we're going to add on to both sides of the equation. So now we're going to come over here. We're going to rewrite the left side. It's going to be 3 parentheses x squared minus 10x, and then we bring in the plus 25. So plus 25 gets added, equals. On the right side, we have 69. And then because we're adding 25 to the parentheses, remember that 3 needs to be added on to the, it needs to be multiplied, to say, to this 25. And so 3 times 25 is going to be 75, which is going to add what we add on to this side. Okay. All right. So now the next thing we'll do is we'll go ahead and rewrite this as a parentheses squared. So that means we're going to have 3 and then parentheses squared. So remember, it's going to be x right there. And then because the half b column says minus 5, we write minus 5. So we have 3 parentheses x minus 5 squared equals, and then we need to add 69 and 75. So I believe 69 plus 75 is going to be 144. So we're going to put 144. Okay. So right now we have 3 open parentheses, x minus 5 squared, close it, and then equals 144. So now the next thing we'll do is solve it the square root method. So we're going to divide both sides by 3. So that's what we'll do. So divide both sides by 3. So that's going to leave you with x minus 5, close parentheses squared, equals, and then 144 divided by 3 is going to be 48. Okay. And so now we do have the squared by itself. So the next thing we'll do, of course, is we need to square root both sides. So let's do that. So we're going to square root x minus 5 squared and square root 48. So that means we're going to have just x minus 5 on the left side equals, again, we write plus or minus because we square root both sides. But 48 is not a perfect square. We can't square root it. So we must do a factor tree. So let's come over here and do a factor tree. So we're going to have 48. We're going to break it up. So 48, we could have 2 times 24. Then for 24, we could do 2 times 12, which means we have a pair right here. Then for 12, we're going to have 2 times 6. And then for 6, we have 2 times 3. And again, we have a pair of 2s, so we circle that pair, but we need to put a box or a square around the 3 because it's unpaired. Remember, we only look at numbers that we did not break up, or if we see pairs, we go and circle them and go from there. So now we go back to our original problem. We're going to write plus, we have our plus or minus already. We're going to write our square root. Remember, unpaired numbers go inside. So we have a 3. So that 3 is unpaired. That goes inside. We have 2 pairs of 2s. So we have a 2 right here, another 2 right there. So that means it's going to be 2 times 2. That goes on the outside of the radical sign. And so, of course, that means that this is going to equal to x minus 5 for the left side, and on the right side, it's going to be plus or minus 2 times 2 is 4, and then we have square root of 3. Then we just need to move the negative 5 from the left side of this equation to get x by itself. So, of course, we do that by adding 5 to both sides, which means we're now going to have x on the left. On the right side, we're going to have 5, and then plus or minus 4 square root of 3. Because you remember, you always write your whatever you brought over first. And then we can simply write our solutions separately because unfortunately 5 and 4 square root of 3 are not like terms. So there's no adding or subtracting we can really do at this point. So that means that our solutions are going to be x equals 5 plus 4 square root of 3, or x equals 5 minus 4 square root of 3. So remember, you just write it just like that. You don't add the 5 and the 4. You don't subtract 5 and the 4 because, again, they're not like terms. So that's going to be your answer for this problem. So, yeah, there you go. All right, so now we're on problem number 9. If you're following along on the worksheet, you'll see that this is basically another irrational solution problem. So that means you know that you're going to end up with having a radical sign in your answer at the end, in your solutions at the end. So let's just go on and get to it. As you can see, the x's are, you see x squared, you see minus 6x, but that minus 31 needs to be moved over so that all the x's are all just on one side. So in order to do that, we're just going to add 31 to both sides. And so that's going to leave you with x squared minus 6x equals 0 plus 31. Of course, it's 31. By the way, we do realize that a equals 1. So if we wanted to, we could factor out the 1, but it's not going to make any difference. So we just go ahead and do that. Actually, just for practice sake, let's just go ahead and factor out the 1. So we'll just write a 1 outside of the set of parentheses. And of course, that means that nothing's going to change because you're just dividing by 1. So it's going to be 1 parentheses x squared minus 6x equals 31. So we have our parentheses taken care of. So of course, all we have to do at this point is just make a B table. So let's do that over here. So again, B, 1/2 B, and 1/2 B squared. Okay, so that means we're gonna have B, which in this case is -6. That was the original B because and it's the new B still because A was 1, so we don't have to worry about really dividing. Then half of -6, of course, is going to be -3. And then -3 squared is going to be +9. All right. Probably seen that plenty of times at this point. So basically, we're going to take the 9. We're going to add that to both sides of the equation. So basically, we're going to have, well, we have 1 parentheses x squared minus 6x plus 9, and then equals, and then we have 31. And then remember, just like normal, we would basically multiply the number that we added on, that add on to parentheses by a. Well, it's just 1 times 9, so it's just going to be plus 9. So that's what we have. So then now the next thing we'll do is simplify. The right side, of course, is 31 plus 9, which is going to be 40. The left side, well, we had 1 in front, but there's no reason to write that anymore. So we're just going to go ahead and write our set of parentheses squared. We know the x is going to start it off, and then half b column is -3. So we write -3 after that x. So right now we have x minus 3 squared equals 40. So now the next thing we'll do is we're going to square root both sides so we can get that, try to solve for x. So we square root x minus 3 squared, we square root 40. That means that the left side is simply going to be just x minus 3 equals, write our plus or minus, and then now ask yourself, can 40 be square rooted perfectly? The answer is going to be no. So then what you'll do is you're going to take the 40 and you're going to do a factor tree for it. So how can you break up 40? We could do 4 times 10, for example. Okay. And then 4, it can be broken up as 2 times 2, which of course means we have a pair. And then 10, it says 2 and 5, but 2 and 5 are both going to be unpaired because we've already have a 2 paired up. And so this is a box, this is a box. And so that means we're going to come over here. We're going to rewrite our radical sign. Unpaired numbers go inside. We have a 2 and a 5. So we're going to multiply that 2 and the 5 because if you have multiple numbers, you're going to multiply. We have 1 pair of 2s, so that is just 1 2. That 2 comes on the outside. And so to simplify this, we're going to have x minus 3 on the left equals, on the right side, you have plus or minus 2, and then square root of 2 times 5, of course, is 10. So that's where we are. And then we're going to move the minus 3 so we can get x by itself. So we need to add 3 to both sides. So that's going to leave you with x equals to, again, write the thing that you brought over first, which is going to be positive 3, and then plus or minus 2 square root of 10. And as you can see, we have a radical sign. So we can't add the 3 onto anything. So the simplest thing to do, of course, is just write our solutions. So that means our solutions separately are going to be x equals 3 plus 2 square root of 10. And then the other one is x equals 3 minus 2 square root of 10. Okay? And so those are going to be my two solutions. And so there is that for this problem. All right, so congratulations if you have watched this far, because now we're going to get to something that we haven't really talked about yet. We're still going to be doing like the same concept, but you'll see real quickly what might be a little different, or what might be different on this problem. Keep in mind that if you're following again on this worksheet, you'll see it says complex solutions. So let's talk about what that means, and we'll talk about that as we progress. Now, we're still going to do our regular thing. We're going to try to do our complete the square. We're going to try to solve for x. So nothing has to change. But again, later on, or in just a moment, you're going to see why it's going to be a little different. Now, we do know that we need to go ahead and move that 43 over. So we're going to subtract 43 on both sides. Okay. And so that's going to leave you with the left side is going to be just x squared plus 12x. And of course, on the right side, it's 0 minus 43, which is negative 43. By the way, we know that a equals 1. So we know that if we wanted to, we could factor out that 1, but it's not going to change anything. But we might as well just do it as far as practice is concerned. So it's going to be 1 parentheses x squared plus 12x. And then on the right side, you still have negative 43. So now that we have factored out the A, I guess, we can go ahead and again do our B table. So again, nothing has changed yet. Okay, nothing's really, everything is the same. So I said I was not going to write that B table word anymore, but it's okay. I've done it. So B, half B squared. So we know that B is going to be, let's see, B is going to be 12, right? Because that didn't change. And then half of that is going to be 6. And then half of B squared is going to be 36. We're going to add that 36 on to both sides of the equation. So we're going to circle it. So remember the 36 on the left side is going to be added into the parentheses. So we're going to basically have 1 parentheses x squared plus 12x plus 36, okay, equals. And then on the right side, we had negative 43. But remember, we need to add on something to it. And remember, since we added 36 to the parentheses, remember you will just need to multiply the A that you factored out to that 36, but it's just 1 times 36. So it's just going to be plus 36, just like that. All right, and now I wonder if anybody sees anything yet, but now we're going to go ahead and write our left side as a parentheses squared. So remember, it's just 1, so we don't have to worry about the 1. Just turn it into parentheses squared. It's going to be x on the left side. On the right side, it's going to be, I mean, not on the right side, but x. And then the half b column tells us it's plus 6, so positive 6. And then on the right side of the equation, it's negative 43 plus 36, which is going to equal to a negative 7. Okay. Now, again, see anything yet? See anything different? Yeah, I think you do. It's that on the right side, it is going to be negative 7. Let's talk about that. Now, we are going to go ahead and square root both sides like we're supposed to. So go ahead and square root x plus 6 squared and square root negative 7. Okay. Now, again, please watch. So now on the left side, you have just x plus 6. equals, and then you have plus or minus, because remember, when you square root both sides, it's plus or minus. But the problem we have here it's a square root of -7. Okay. And if you go to your calculator right now and you were asked to, and I asked you, go to your calculator and square root -7, you're going to get an error. Okay. Because the square root of -7 is what's called an imaginary number. It's not real. Okay. Some calculators they even say that if you put the square root of -7 in, it's going to be a non-real calculation. But the square root of -7 is, like I said, is an imaginary number. Okay. And so this gives me a chance to talk about that very briefly. And so basically what that means is that whenever you see a square root of -7 or any square root of a negative number, automatically that means that you're going to put the letter I, okay, right here. So you put the letter I and then return to writing just the square root of 7. So what I'm trying to get you to understand is that whenever you see, so basically the letter I is an imaginary number that represents the square root of -1. Okay, so you need to kind of remember that this is basically what imaginary numbers are. It's all based off of this fact. I is equal to the square root of -1. And so basically, when you see a negative number in the square root, what that means is you basically take the I out. Okay, I know it sounds gory, but you take the I out, considering what week this is, but take the I out and then leave the positive inside. So it'll just be plus or minus I square root of 7. Now, normally I would say at this point, well, let's take 7 and do a factor tree for it. But I hope you know though that 7 is a prime number. The only way to get 7 is 1 times 7. So we have to leave it as it is. So the only other thing we have to do now at this point is we just have to take the 6 and move that to the right by subtracting 6 on both sides. So it means we're going to have x on the left equals, on the right, it's going to be -6 plus or minus I square root of 7. And so that's as far as we can go. So that means that all we got to do now is just write our two solutions. So our two solutions simply means that our solutions are going to be x equals -6 plus I square root of 7, or x equals -6 minus I square root of 7. So those would be my two solutions to this problem. These are complex solutions because they include the letter I, and the letter I in math means the square root of -1, and that's an imaginary number. Okay, so there you go. All right, we have this last example we're going to do, number 14. We have 3x squared minus 6x plus 80 equals -4. And again, remember, this is on the complex solutions problems. So we know that we're going to end up having, like we had in the last problem, an imaginary number situation. So, but we're going to start off, of course, by letting us know that we do have a value of a. A is going to equal to 3. What we also know is that 80 needs to be moved because we want to make sure that we have just x's on the left side. So to do that, we are going to subtract 80 to both sides. So that means that we're going to have 3x squared minus 6x equals, and then we have -4 minus 80, which is going to be -84. Okay. All right. So this is where we are at this point. So now, because A is not 1, we are going to go ahead and factor out that 3 to the terms on the left side. So that means that we're going to have 3 and then open parentheses and then equals -84. So once again, we'll have to do some side work. We haven't done that in a little bit. So we'll do some side work. So we're going to have 3x squared divided by 3, which of course is going to be just x squared. So we'll write that at the beginning. And then we have -6x divided by 3, and that's going to be -2x. So it's going to be -2x right there. And so now that we have factored out the 3, we can go ahead and, of course, do our B table. So let's do our B table. So again, our heading is B, 1/2 B, and 1/2 B squared. So that means B is going to be -2, because remember, we look at what's inside the parentheses next to the x. So that's -2. Half of -2 is going to be -1. And then -1 squared is going to be +1. Okay? That 1 that we got, it's going to add it, excuse me, to your both sides. So we're going to go ahead and circle that 1 that we have here. And so we're going to go back to our problem. We're going to add that 1 into our parentheses. So it's going to be 3 parentheses x squared minus 2x plus 1. Okay. And on the right side, it's going to be -84. But remember, we have to add on what we added on to the parentheses, but times it by a. So remember, this 3 gets multiplied to this 1. So that's just 3 times 1, which is going to be +3. All right, I like how this is going to work out, kind of, actually. So that means we're going to have 3, and then we're going to write it as a set of parentheses with squared. So remember, the beginning of the parentheses will, of course, be x, and then the half b column is going to be -1. So we're going to put -1 squared, and then equals, and we have -84 plus 3, which is going to be -81. Okay, yeah, I think I like how this is going to work out. So now the next thing we're going to do is we're going to get the squared by itself. So of course we do that by simply dividing both sides by 3. So divide each side by 3. That means we're going to have x minus 1 squared equals, then we have -81 divided by 3, which is a -27. Okay. And so we do have the squared now by itself. And so, of course, that means that we need to get rid of the squared. So we'll do that by dividing, and it's not dividing, by square rooting, which is a form of dividing, but we are going to square root. So we're going to square root x minus 1 squared, and we're going to square root -27. So the left side is going to be x minus 1, okay, because we square rooted that, equals plus or minus. And then we notice that we have a negative inside the square root. So automatically we're going to go in and write the I, because remember that I equals the square root of -1. Don't forget that. I equals the square root of -1. So we have the I, and then we're going to, we basically factor out the I, and then we have the square root of 27. So that's what we have at this point. We have x minus 1 equals plus or minus I squared root of 27. And so now we do need to go ahead and try to do a factor tree for 27, because we can break that up. So let's go and see what that helps us do. So 27 broken up is going to be, we could do 3 times 9, all right? And then 9 can be broken up to 3 times 3. And so we're going to circle a pair of 3s. So I'll circle this pair, and then the 3 that's here is lonely, it's by itself. So now all we have to do is come back to our problem, and we're going to write it like this. It's going to be x minus 1 equals plus or minus. I'm going to write my square root. We know that the unpaired number is 3, so we have a 3 that goes right here. And then we do have a pair of 3s, so that does come out as 1 3. And we're going to put that 3 in front of the I that was already outside. So it's going to be 3I. I mean, because we usually like to put the number in front of a letter. Now, remember, the letter I is not a variable. It equals to an imaginary number, the square root of -1. But it's good to put the 3 in front. It looks better. 3I instead of I3. Okay, so 3I. And then all we gotta do is move the -1 on the left side so we can get x by itself. So we do that, of course, by adding 1 to both sides. And therefore, we're gonna have x on the left. On the right, it's gonna be 1 and then plus or minus 3I square root of 3. Remember, whatever you brought over needs to be written before that plus or minus. And then finally, we can write this into two solutions. Yeah, we can write our two solutions. So that means that our solutions are going to be x equals 1 plus 3I square root of 3, or x equals 1 minus 3I square root of 3. And those right there represent our solutions to this problem. Okay, so really the only thing about complex solutions is that if you have a square root of a negative number, you just got to take that I out, and then um, basically be able to and then basically, like I said, be able to go and find our solutions from there. So, and then if you got a factor tree, the number is still inside the square root, then that's what you do. Okay. All right. All right, we got through a lot of problems, so I really do appreciate you watching the whole thing. If you did, if not, at least you went to go look at the thumbnails and the chapters and went from there. So, but either way, I do appreciate you watching the video, and if and I guess to make sure somebody is listening to this, I guess a question I can offer for some points on to an assignment, maybe even on our future problem set day, would be what again is an imaginary number? What is the general definition of imaginary number? If you can send me a message with that, then with your name and everything, then I'll be glad to give you some points for that. I'll give you 5 points, perhaps on to yeah, that's actually what I'll do, just to make sure everybody's listening. 5 points added on to the problem set for October 31st, 2025. So, but thank you so much for watching this video. I did make this around around about 2:30, 3 o'clock in the morning. I sound awake, but thank you for watching this, and I look forward to seeing your work on future problems. And I hope you have a great time and a great day, and look forward to seeing you again soon.